Hey everyone, I'm sure this is something you could all relate to in this day and age. Picked up a nice set of headphones on Amazon. This is a Soundcore Life Q20, and it's purported to have 40 hours of playback time on a 3-hour charge, which I believe it did. And as you look at the reviews, it's either got excellent battery time or terrible battery time, or somewhere in between. You never really know with these reviews, but I'll tell you right now, mine got awesome battery time until it didn't. And now it's got like nothing. And this thing is like brand new. I just used it at the gym. You'd think I just got it out of the box, even though it's a couple years old. Still got the original plastic wrapping on it. Look at this thing. But on the full charge, it says battery full. Hour later, it says battery low. And then 5 seconds later, battery empty, and it's dead. And I picked this thing up October 2021. Before taxes, it was $50. Same one now, due to inflation, costs $60. And you can't just drop the batteries right out like old headphones. They're built in. So what are we to do? They're a great pair of headphones. They sound really good. How quickly can we repair them? How cheap can we do it? Let's find out now. I'll pull off the padded ear muff on the end. They look like they snap in. And I'm trying to be careful because I don't want to break it. And it is coming off, and it is removed. There are 4 screws we see here under it. And I'm starting with the right one because I see that the power connector to charge it is on the right side. So these 4 screws, I'm going to remove them now. And I'll need a very small Phillips head to do this, using from my Radio Shack set. Now lifting away at the small speaker cabinet, looking under, I see a circuit board. I do not see a battery, though it is possible the battery is under the circuit board. So we're going to have a look under there now. And though there's more than one screw hole here, there's only one screw holding this thing in. It kind of floats in here. So we're just going to remove that one screw supporting this. And now I'll be able to lift up that circuit board to hopefully expose a battery. So we'll have a look under here now. And we got nothing. So just that processor here, that computer chip. Aside from that, I would guess the battery is going to be on the other side. We're going to reassemble this. So I've lined everything back up, and I'm going to put that one screw back in where I found it. Snug it down. Make sure all the buttons are still working properly. I find this out so nobody else has to do this. It's not on the right side. I put the cabinet back into position. Don't break anything. Do no harm is the first rule. And I'm just going to screw everything back down. And lesson learned. I still felt like the side with the charger would have been my first choice. Would have been where the voltage regulator was, close to the battery. Turns out I was wrong. So we're ripping off the padding on the left side now. And we're going to pull these screws off. I hope we get lucky. Other than that, it's probably in the headband. But we'll see. Removing the speaker cabinet. And we got a battery. There we go. Lithium ion battery pack. 720 milliamp hours it looks like. Having recorded which way it was plugged in, red is on the right in my position. I now disconnect it. And using a screwdriver, I just pull the battery up, the adhesive holding it in, popping it out. We get a closer look at it. 720 milliamp hours, 3.7 volts, standard fare for a headphone battery. Measurements show the case that it was inserted in is significantly larger than the battery, so they probably went a cheaper route with a smaller battery to save money. And 902532 is actually quite difficult to find. 102535, this larger battery, was readily available, and the dimensions allowed it to fit just fine into this headset. Waiting for me upon return from vacation. The upgraded battery brings it from 720 to 850 milliamp hours, an increase of over 18%. Same height, same width, and while longer, should fit without any issues whatsoever. The connector is, however, different, so we're going to have to swap over the cable from the old battery to the new. Conducting a quick test fit with the new battery, and we see that this thing just fits perfectly. Snaps right in like it was designed to be there. Look at this. So they saved some money on each one by putting in a smaller battery. But now we got to deal with the connector. So I'm going to show a method for those who might be shy about soldering and desoldering from these lithium ion batteries. We're just going to do it right off of this cable, cutting from one side at a time, working with one connection so we don't short it. Black is first. And I'm measuring up some heat shrink I'm going to use for this application, and it's going to be 1/16 of an inch heat shrink. Cutting the black on the other side, and a small length of heat shrink. I put the heat shrink on the longer of the two black connections that are about to be fitted together. Scoring off the insulation very carefully so I don't remove any of the wire. There's not much wire to work with. I then score off insulation from the other side, just turning the wire as it touches the razor blade. I'm able to pull off the insulation and then twist the two onto each other as I pull back to make a union. And I want to make sure that that union is twisted really good and tight. I'll look at it carefully, and once it's good, I'll move over to the soldering station, adding flux onto that union to ensure the solder wicks in quickly and doesn't melt the heat shrink. And then I'll solder it. It flows into the wires, in between the wires really quickly, so the heat shrink doesn't melt, and that connection is completed. Allowing a few minutes to cool, I'll push the heat shrink over that connection, and centered, I'll then hit it with a lighter so the heat shrink shrinks, sealing that connection and completing the black connection. Repeating now the same process for red, I'll remove the old battery, cutting in a different location on that cable so the two connections are not at the same location. Everything will be scored again for the insulation removal. Heat shrink will be applied, everything will be tied back together, back to the soldering station where flux is applied, and then the cables will be soldered together. Heat shrink, then fire, then finished, and this cable has been successfully moved to the new battery. For a more experienced person, this would have been quicker and easier removing the cable directly off of the battery. This starts with the cutting away of the special high temp tape, which obviously you'll have to have on hand. I'm using the old battery as an example for this because I've already made the connection with the new one. Unfolding where the ICs are for the charging controller and protection. We could see that there's more tape to peel away after it's unfolded. And as I peel it off the other side through the wires, the tape is removed, exposing the board and the two wires that were there originally. Heating up the pad carefully is to not short it to the other pad. I remove the wires one at a time. I then make sure the solder on the pads looks good and I touch it up as necessary. These pads now look just fine for installation. If too much solder was removed, I would just apply solder very carefully, again as to not short the battery as demonstrated. And then I would carefully tack on the new wires to the terminals like so. I'll point out that I'm doing it in the wrong direction, but this is again just a demonstration. Tack on the second wire, again being very careful as to not short them together. And this one looks good, but I would have been following the original path of the wires for this battery. It would have been pointed inward. But now I'm going to apply the tape, and obviously I would have been using the same method that was used before the old wires were removed, but I'm just demonstrating this fact that the wires would be insulated with this tape and then it would be folded. Originally this cable would have been on the inside, folded coming out the side, but again just a demo, and then another piece of tape would go around to seal it, and then we would have ended up with a cable coming out the side and insulated and soldered. But obviously this could be a little bit different. This example piece was too short for that. But yes, in the end, it's a lot quicker to solder them right to the terminals and retape it if you have the tape and the know-how as to do the procedure like this. We'll continue with the installation. Knowing which way the connector goes in, it will be bent on a 90 degree here, so it's easy to plug in under that board. Pushing it partially in and then mostly in with my finger. A flathead screwdriver against the connector pushes it in to seat it all the way, like so. And now the battery is installed. I'm using Velcro to support this new battery, so I'm cutting a length of Velcro now, which I'm sticking to the back of the battery before I install it into the case, in case I have to remove it for more testing. So I'm removing that backing, and now I'm installing it into the unit, and that'll support it while it's in here with a cushion. Now it's fully installed. I'm putting the earmuff back on the right side because there's no reason not to, and it's also the charging side, and I'm about to use this side for charging. I don't want to damage the speaker. So now I plug in my charger cable, the big moment of truth, no smoke, and I look and I see the red charging light on the other side. So now we're going to wait, 4 hours to see if it fully charges. So we're going to come back and see if this upgrade worked on these headphones. The red on the wall charger shows it's pulling current, so I'll wait for this to turn green and have a look. A couple hours later, it's green, and the charging light is off on the headphones, so that's a good sign. So we'll pull the power cable now and fire it up, but it'll be hard to hear. It came on and said battery high. So now I'll shut it off and we'll reassemble it. I found the Velcro gets in the way, raises it too high, and the battery this size fits in perfectly. It's secured by the plastic, so I'm removing that Velcro now. And we push this right in and snap it into place. And not only is it held from the bottom, but the top of the speaker cabinet holds it in. There's a piece of plastic there that does so. So that's just fine like that. One last check of everything. It all looks good. So we're going to close the cabinet now over the headphones. It sits good, no binding at all. We'll drop in the screws and tighten them down. Not all in, we'll just give them a little snug. Now we'll place the foam pad back on the left side. And that's it. These headphones are repaired, fully charged, and ready for testing. I'll go to the gym and see how many hours I get out of it. About 9 trips later to the gym at around an hour each, it still says battery full when I turn it on. I'm going to call the test here for this video, but I'll update the total in the comments below later. I remember 20 years ago, items like this would have a door on the side where even a battery pack such as this could easily be swapped out with a connector just like this, no problem at all. Those days seem to be behind us. So I hope you found this video on the battery swap / upgrade of these Bluetooth headsets enjoyable, entertaining, and informative. Do me a favor, hit that like button down below, helps me out a lot when you do, and hit that subscribe button for more videos like this when they come out. Again, I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?